As developers, a lot of what the software we write does is move data between devices like computers, phones, servers, and peripherals. It's so routine we rarely think about it, and it often doesn't matter. Until it does. Maybe we need to transfer terabytes of company data to a new remote server. Maybe we need to transfer a small amount of data as soon as possible. That's when the transfer method starts to matter. So, what's the fastest way to do it? Before we get into the specifics, we need to make a few clarifications. When we talk about the speed of transferring data, we generally mean one of two things: throughput/bandwidth, how much data are we sending per second, and latency, how long until the first bit arrives. For the purposes of the video, we'll rank the methods by throughput, but we'll mention latency and other related factors wherever it's relevant. Let's go. Let's first look at Bluetooth. It's designed for short-range, low-power connections with real-world throughput around 2 megabits per second. That's enough for streaming music to your headphones or sending a photo to a nearby phone. But try moving a few gigabytes and you'll be waiting hours. Bluetooth optimizes for power and convenience, not bulk. So if your data transfer needs are local and small, this could be your choice. Keeping with the wireless theme, let's now look at Wi-Fi. Wi-Fi 6 is currently the most widely used standard and tops out at a theoretical 9.6 gigabits per second. In practice, you'll see anywhere from 500 megabits to 1 gigabit per second, depending on your hardware, distance from the router, and how busy the airwaves are. Wi-Fi 7 pushes the theoretical max to 46 gigabits per second, with real deployments hitting 6 to 15 per access point, though a single device usually sees just a few gigabits. Wi-Fi is convenient and cable-free, but it's shared and interference-prone, meaning real-world speeds depend on your environment as much as your hardware. By the way, if you think you're learning something, leave a like. And if you've got questions, the comments are open. I read and answer them, and the good ones sometimes turn into entire videos. To go faster, we need to get into the world of cables. In homes and offices, the most common type is twisted pair copper. Pairs of copper wires twisted together inside a plastic jacket, ending in the familiar RJ45 plug. Cables come in different grades: Cat5e, Cat6, Cat6a, and so on. And the grade determines which Ethernet standards can physically run over them, which in turn sets the speed. Cat5e handles 1 gigabit per second. Cat6 stretches to 10 gigabits over short distances, and Cat6a holds 10 gigabits all the way to 100 meters. Keep in mind, these speeds are the cable's potential. What your ISP actually delivers over copper is usually much less, typically a few hundred megabits to maybe a gigabit. For specialized use cases like data centers, there are even higher grade cables that push these speeds further. Wired connections are predictable and consistent. What you measure is roughly what you get. If we want the best of what wired connections can do, we need to get our fiber. Fiber optic cables, that is. Instead of electrical signals through copper, fiber sends pulses of light through thin strands of glass. Light loses little energy over distance, so fiber supports longer runs and higher speeds. In many places, fiber is also how you get a true gigabit connection at home, with symmetric upload and download speeds and providers offering plans up to 5 or 8 gigabits per second. Across the Internet's infrastructure, the links between ISPs and data centers reach 800 gigabits per second per port. Fiber dominates on both throughput and latency. It's the backbone of the modern Internet. And now for the plot twist. If you have a huge amount of data, meaning more than a few hundred terabytes, give or take depending on your connection, there might be a faster way. And it's one that existed before our previous options. SneakerNet. The idea is simple. Write your data to a stack of hard drives, load them in a truck, and physically deliver them. Computer scientist Andrew Tannenbaum captured this decades ago. Never underestimate the bandwidth of a station wagon full of tapes hurtling down the highway. XKCD calculated back in 2013 that FedEx's entire fleet had effective bandwidth around 100 times the Internet's. The exact numbers have shifted since, but no fiber link comes close. This isn't a thought experiment either. Major cloud providers offer it as a real service. Azure ships you a data box, Google offers a transfer appliance, and AWS used to do the same with Snowball. The catch, of course, is latency. SneakerNet wins on throughput by an enormous margin, but the first byte takes hours or days to arrive. Great for moving a petabyte, useless for moving a tweet. Of course, there are plenty of other ways to move data: satellites, cellular networks, NFC, USB cables, even a flash drive in your pocket. But we've covered the most relevant stuff for developers. To become a better developer, consider subscribing to the channel. I make videos on a variety of software topics. Like my previous video, Computers Suck at Random Numbers. I have so much interesting stuff coming. Bye!